see, integral calculus. Yeah. Now see, integral calculus uh, is the reverse of differential calculus. Now let me give an example. If I say that, if I say that sine 30 degrees is half. Okay.
Mm-hmm. Mm-hmm.
Okay. Tan 45 degrees is 1.
Mm-hmm.
Now the reverse of this would be sine inverse half is
30.
30 degrees.
Mm-hmm.
Similarly, tan inverse of 1 is
45.
45 degrees. Now, of
Mm-hmm.
course, this I have simplified a lot because if you see an inverse trigonometric equation will have infinite solution. Okay, as we'll be
Okay.
knowing. Okay, but we
Mm-hmm.
only talk, we are talking about the principal value. So this is the concept of function and reverse of a function, correct? Which you would be knowing already. If I say y is equal to x square,
Mm-hmm.
then the inverse would be x equal to root y. So we write it as y equal to root x.
Mm-hmm.
That's the inverse of this. So if f of x is x square, f inverse x square is root x. F
Root
inverse x,
x.
f inverse,
X.
yeah, f inverse x is root.
Uh-huh.
This is
Okay.
what it is. Now,
X is root x.
similarly, yeah. Now similarly, if I say, if I say, um, if I give you a function, let us say, a function is here.
Mm-hmm.
Okay, if I say my function is here, y equal to f of x, and we write dy by dx is
Mm-hmm.
f dash x. Is it recording? I hope it is. Yeah, it's recording. It's recording.
Okay. Perfect. Perfect.
Now, is it
So
cold
just
in?
by the way, sir,
Uh-huh.
it's cold here.
I'm asking you.
I mean, sir. I mean, it's very cold in Germany at the moment.
Okay.
Like almost 2, 3 degrees, 1 degree. It's pretty cold.
Okay. Okay.
Uh,
It's
sir,
like,
but
but
what I was going to say, sir, that sir, like let's do this only. But I had one doubt, small doubt in chi-square. I was doing something, and I'll ask you at the end of the class. Okay,
okay.
about the chi-square.
Okay.
Okay.
Okay. Have you solved that worksheet which I gave you?
S- Sir, yes. Wait 1 second. No, sir. Not all the sums.
You
No.
should solve. See, I'll tell you why. Okay. We agreed to a routine.
Okay.
I'll give you advanced
Correct,
video.
sir.
So I put advanced
Mm-hmm.
video of integral calculus. Now when I'm doing, okay, we will, the understanding will be better. Now whatever we are
Correct,
doing
sir.
today, I'll put a worksheet. Okay. So then the learning is complete. Okay.
Right, sir.
Okay. We follow that.
Sir, but actually, sir, not sir, excusing, not giving excuse, but I actually did. I mean, there was no worksheet, na, sir. Like you said, you put on a classroom, but there was no worksheet in classroom, no. I also forgot to ask, my fault, but there wasn't any worksheet on classroom, so
There's no
yeah.
worksheet in classroom.
No, sir.
Acha. Okay. Okay.
Okay, sir. Anyway.
Okay, okay, then okay. I'll be careful.
Okay, sir. Thank you.
No, because see the thing is, no, we don't have the luxury of time.
Absolutely, sir. I mean, and so I also need to do the worksheets just to get the practice and correct thing, correct flow going.
Okay. What I do is, all my worksheets,
Mm-hmm.
everything, is from an IB resource.
Okay.
So, it could be Oxford, it could be cognitive, it could be in
Huh.
thinking, it could be revision village, it could be anything. Okay. But
Okay.
virtually, whatever I can lay my hands on, I
Mm-hmm.
I put in the worksheet. So as a result,
Okay.
no, I will not say that 100% of the questions are there. I will not say that, but definitely, uh, let them ask any question in the exam.
Mm-hmm.
There is a 95% likelihood that you would have seen a similar question in my worksheet. Definitely.
Right, sir.
Because
Those are done, sir. Like, I mean, sir, from now on, sir, everything we do is send a worksheet.
uh,
I'll do it. Pakka 100%. I'll do
because
it and send it.
because right now we have to be extremely focused.
Right, sir.
So we don't have the time for exhaustive study.
Correct.
So whatever we do, it will be only with the focus on ID.
Huh,
Okay.
sir.
Okay. Now see. Now if I say derivative of x, if f of x is x, what is derivative of x? It is
Huh.
it's one.
Huh, sir. Correct.
If I say derivative of uh, x plus 100, so derivative of x plus 100 is how much? You know
Give
derivatives, huh?
Sir, I do know, sir, but the thing is, sir, the actual derivatives that I've forgotten a bit. Like recently, I did that long back, sir. Last year on end, not last
Okay.
year, like this year beginning.
Okay. In derivatives, what have you done? Derivative of x. One second. What I'll do? I have a better idea. Just give me 1 minute. I will upload this document here, so we will know what is there. What we have to do is now they will give you a formula booklet.
Mm-hmm.
So you use the formula booklet because it is no point trying to commit to memory. It's no point.
Right.
Yeah, this one.
Booklet, yeah.
This is the formula booklet. Okay. Okay. In this, now let us see, they would have given how many pages? Yeah.
Sir, I was just wondering, sir, I mean, just a suggestion. How about we go over the differential calculus and then come to integral?
Why not? Why not?
Huh,
We
sir,
have to.
please.
We will have to do that only, because
Yes, sir.
finally integral calculus is the reverse of differential calculus.
Right.
We'll do that.
Okay.
I'm just saying to what extent formula booklet will be helpful.
Mm-hmm.
And have I made you the formula booklet? Okay, sin x.
Uh,
Acha, okay.
sir,
No, we have it. We have
uh,
it here.
okay.
Sin x, cos x, tan x, e raised to x, ln x, and chain rule. Okay. That's it. I just wanted to confirm this. So,
Mm-hmm.
whatever we have readily, we will use that. Okay.
Okay. Okay.
Okay. Sin x. Okay. So, okay, we start with differential calculus in that case. Now see, I will first explain the concept of differential calculus.
Mm-hmm.
Okay, and then we will see. Uh, so I'm deleting all this. Huh?
Okay, sir.
Now, okay. Uh, can you see this decimals?
Yes, sir.
Okay, fantastic. Okay, now let us say I have got a curve
Mm-hmm.
y equal to x square.
Mm-hmm.
I think I'll make it x square upon 2 or upon 100 so that the curvature is, oh, that's too much. No?
100.
This is okay. X square upon
Okay,
2.
huh. Mhm.
Now see, um, let me take a point here. I've got a point here.
Ten, 10.
When x is 10, y will be 10. No?
Mm-hmm.
Okay, correct. 10, let me mark this point here. Yeah. Ah, do you see this point? 10, 10 like
Yes,
this.
sir.
Okay.
Huh.
Now, suppose I have another point. This is the dynamic point, I call it. Mm, A comma B.
Okay.
Now see, what I can do now, I can move this A comma B on the curve,
Mm-hmm.
on this curve, this curve. If I move A comma B, what will happen is, if you see, if I join these 2 points, point A comma B and 10, 10.
Mm-hmm.
Yeah. Now see, if I join, no, what is this? Correct. Now see, when I join these 2 points, I get a line segment, right?
Uh-huh.
You see it? Okay.
Yes,
Now,
sir.
now, what is the slope of this line segment? The gradient.
So it'll
Uh,
be b minus 10 divided by 10. Sorry. 10 minus b divided by 10 minus a.
Perfect. Okay. 10 minutes. We upon 10 minutes. You're right. Okay. That's the gradient.
Mm-hmm.
So let me just. Okay. It'll be 10 minus b upon 10 minus. Hmm. Okay. It'll be 10 minus b
Mm-hmm.
upon 10 minus gradient is. Now suppose I'm moving this point close to 10, 10. 10,
Mm-hmm.
10 is fixed.
Mm-hmm.
Now, okay. Suppose this point is here at 0, 0.
Okay. Mm-hmm.
At 0, 0. What is the gradient when the point is at 0, 0?
When the point is at 0, 0, the gradient is 10, I mean 1.
1. Okay. So I'm making I'm using this calculator, so it will calculate alongside.
Mm-hmm.
10 minus 10 minus b
Mm-hmm.
upon 10 minus. Okay. So it's 1. Okay. Now, right now, A and B are not exactly 1. If A
Mm-hmm.
and B, if I move on this, it will be 1. Okay. Now, see.
Right, sir.
See, this is because of human error. Okay.
Mm-hmm.
1.016. Now, if I move this point on the curve, okay, my point is moving on the curve, but closer
Mm-hmm.
to 10, 10. So suppose it's moving
Mm-hmm.
closer. What do you see? Now it is 1.313. When
Mm-hmm.
you see my coordinates are here. When A
Mm-hmm.
is 2.95 and B is 0.74. Okay, it is 0.5. Correct. So you understand? A is
Yes, sir. Uh-huh.
now. Do you appreciate that? A B is a point on the curve, right? So B
Mm-hmm.
is equal to x square.
Mm-hmm.
See, this curve is y equal to x square. This curve is
Y equals to x square.
so
So
my
B is
point
also
A.
equal to x square.
So B is equal to x square. Okay, now see 1.313. Now I move it now when A is, which means when x is 2.95 and B is 0.7.
Mm-hmm.
Okay. Now again has to move closer. What do I have? 1.476.
Mm-hmm. 467.
Okay. 467. Yeah.
Mm-hmm.
1.467. When A is 4.85 and B is 2.44.
Mm-hmm.
Right? Am I right?
Yes, sir.
Uh, okay. Now, when A is, again you're moving closer and closer and closer. What do you see? It's increasing.
Mm-hmm.
Now, as you move B closer and closer to this line, to point, what happens?
Still
You see,
increasing.
earlier it was, the line was like this, you see?
Correct. Uh-huh.
Now it's getting closer and closer and closer and closer. All the time I'm moving on the curve. Yeah?
Mm-hmm.
Hmm? When A is 7.65, you see these values here. No? When A
Yes, sir.
is
Uh-huh.
7.65 and B is 6.15, my
Mm-hmm.
gradient is 1.64.
Right.
Again, when I go still closer, 1.89. Still closer. Now you
2.
see 1.88, 1.95. You see, as my point moves closer and closer to 1010,
Mm-hmm.
my my gradient, you see, is approaching 2.
Mm-hmm.
See, 2.25, E2. Okay.
Mm-hmm.
And what's happening to the line? That line is becoming a tangent.
Correct. Huh? Correct.
You see, here it was the chord, the
Mm-hmm.
second. Now this line is becoming a tangent.
Correct. Yeah. Correct.
You notice this?
Huh, sir.
Okay. So this is my, okay. Now let us see. Now this is the geometrical interpretation of tangent. Now what is,
Mm-hmm.
sorry, derivative. Now what is
Yeah.
derivative?
Yeah.
Derivative is, see, if I say this is point A, or let me speak in the more general term. If
Mm-hmm.
I say this is my curve, any curve, I have a point um, A comma B, or
Mm-hmm.
y equal to f of x. Okay, now I have a point
Okay.
A. This point will be A and f of A.
Mm-hmm.
Hmm? This is A and this is,
Mm-hmm.
is that right?
Correct. Yep.
I have another point here. Yeah, I have another point here,
Mm-hmm.
which is, okay, now suppose this distance is h.
Mm-hmm.
So this becomes A plus h, yeah,
Yep.
and this, I mean, this becomes f of A plus h, no?
Yep. Correct.
Correct, no?
Yeah.
Correct, no? This is
Mm-hmm.
this is A plus h. This one.
Mm-hmm.
So this point, if I say point A and point B, then what is my tangent? My bigger part, my gradient of AB, gradient what y equals to
Mm-hmm.
f of A plus h minus f of A upon A plus h. Is that correct?
Right. Yes, sir, that is correct.
Okay. Because the coordinates of point B are A plus h and f of A plus h, right?
Mm-hmm.
Okay. Now, this is my gradient of AB.
Mm-hmm.
Now, my h is this. Now, which means f of h. Correct? This is
Mm-hmm.
it. Now, what is h? H is the horizontal distance between point A and point B. Right?
Mm-hmm.
Which means the change in x.
Uh-huh.
The change in the x value. Okay, x is here, y is here.
Yep.
So h is the change in x value.
Mm-hmm.
Okay, is that clear?
Yep.
Okay, now see, what does this mean? Okay, now you see my y is changing from y to y plus delta y.
Mm-hmm.
No, in fact, I have placed the cart before the horse. I should say x is changing from x to x plus delta x. My
Mm-hmm.
delta x is h, no?
Correct.
It
Yep.
changes from a to a plus h.
Mm-hmm.
It changes from a to a plus h. Correct? So my
Correct.
delta x
Yep.
is, and my y changes from f of x to f of x plus delta x. Okay, because y corresponds to x, y plus delta y corresponds to x plus delta x.
Mm-hmm.
Is this clear?
Yes, sir.
Uh, you want me to explain again?
So, no, sir, I'm like, so this is like just a diagram, no? I understood. So, but like,
Okay,
what is the point?
my point is, okay, now see, f of a plus h minus f of a, or in general, f of x plus h minus f of x, okay, is
Mm-hmm.
what? Delta y,
Correct.
okay. Now, x plus delta x minus x, or which is h, okay,
Mm-hmm.
x plus h minus x is delta x.
Uh-huh.
So my delta y upon delta x is the gradient of AB.
Yep.
Now my gradient of AB is delta y upon delta x. Now, now I will make a point, okay? I will
Mm-hmm.
assume that you've understood whatever has been
Yep.
discussed so
Mm-hmm.
far.
Right,
Okay.
sir.
Now this means that when my delta x is very small, which means when my h is very small, when
Mm-hmm.
delta x equal to h is very small, it tends to 0. You know this
The
notation, right?
derivative need. Yes, sir.
It is very
Tends
small.
to.
Now what happens? Okay, my
Then
delta,
derivative is lesser? No, small
yeah,
means.
no, delta y, delta x is very small. I brought that point close and closer and closer.
Correct, correct.
So that
Yep. Mm-hmm.
delta x, no, change in x is very, very small.
Mm-hmm.
So my dy upon dx, okay, my dy upon dx is defined as delta y upon delta x when
Mm-hmm.
delta x is very small. Are you aware of limits?
Yes, sir.
Are you
I
sure?
am.
Are you sure?
Yes, sir. So I'm like, so also being very honest, I don't remember everything about this, but once I practice me for a day, I'll remember
Okay.
100%.
So as my delta x tends to 0. Okay. Neil, what will happen? Suddenly the meeting will stop, huh? Because it's a 40. So I will refresh the meeting.
Okay.
Just bear with
Okay,
me
sir.
for
Okay.
1 or 2 minutes. Just 1 second. Huh? One second. I don't know why.
Yes, sir, of course. Hmm.
Just 1 second.
Mm-hmm.
What happened? Uh, uh, what is it actually? You wanted to say something? I'm sorry for the interruption. Huh?
No, no, sir, no problem.
Now, when my delta x tends to 0, when my delta x is very small, and
Mm-hmm.
when my delta x is very small, okay, what is delta? What is this delta y upon delta x? It is gradient of the tangent. It is gradient.
Okay.
Of tangent.
Mm-hmm.
If I tell you, okay, if I say y equal to x raised to 3 plus 4x,
Mm-hmm.
okay, now dy by dx is I will just write it down now.
Okay, sir.
And you can assume it's God given 3x square plus 4.
Mm-hmm.
Now, when x is 0, y is also 0.
Mm-hmm.
Correct? Na? But in this
Yes, sir,
curve,
of course.
okay, okay. So now, if I say dy by dx, dy by dx
Mm-hmm.
at x equal to 0
Mm-hmm.
is what? 3x plus 4 at x equal to 0.
So that will be only 4.
So that 4, that's running out of time. Oh, good. I
Huh.
love it.
Huh. Okay.
Okay. So now, that will be 4, which
Mm-hmm.
means 4 is the gradient of the tangent
Mm-hmm.
to 3 to x, tangent to x cube plus 4x. My
Plus
curve is
huh.
x cube plus 4x. My
Right.
curve is x
X2
cube.
plus
I
4.
think I can stop this now. I'll change. My curve is x cube plus 4x. Let me draw that curve. X cube plus 4x is my curve. Okay.
Mm-hmm.
Now, if I draw a tangent to this curve, okay, at this point, at x equal to 0, the
Mm-hmm.
gradient of the tangent is 4. This is what is. Okay, have you understood
Okay.
this?
Yes, sir.
Now, what is? Okay, no, see, every time we will not have, okay, time to do all this geometry.
Mm-hmm.
So there are some formulae. Okay,
Okay.
so you remember just d by dx of x raised to n
Mm-hmm.
is n times x raised to n minus 1. Okay,
Right, sir. Huh.
okay, which means if I have x raised to 5, so d by dx, it is recording, so don't worry,
Okay,
of
okay.
x raised to 5 is
Mm-hmm.
5 times x raised to 5 minus 1.
Huh. Correct.
If I say d by dx of x raised to minus 3, that's equal to minus 3 x raised to minus 3 minus 1,
Mm-hmm.
which is equal to minus 3 x raised to minus 1.
Mm-hmm.
Okay. Have you understood this?
Yes, sir.
Okay. So this is a formula, one formula. Okay. Now you don't have to remember the formula. Like
Mm-hmm.
the formula booklet, it tells you that derivative of sine x is cos x.
Mm-hmm.
Is sine second derivative of sine x is cos x.
Mm-hmm.
Then derivative of cos x is minus sine x.
Mm-hmm.
Okay. These are given to you, and you don't have
Okay.
to mark it up. You can actually prove it. Huh? We can
Mm-hmm.
we
Okay.
can we can prove it using this. This is called derivatives from first principles. Okay, which is
Okay.
not there in your
Okay.
portion. It's not there.
Mm-hmm.
Don't bother. Okay. So
Mm-hmm.
derivative, but from first principles we can prove all these. Huh? Then
Okay.
derivative of
Okay.
tan x, derivative of tan x
Mm-hmm.
is sec square x.
Okay.
Okay. And derivative
Right. X square x. Okay.
of
Huh.
e raised to x, v raised to x,
Right, sir.
and derivative of ln x is 1 upon.
Okay. So these are all the base formulas, right?
Yeah, these are
Okay.
given to you. You can derive,
Mm-hmm.
each of these can be derived, okay?
Mm-hmm.
All these can be derived. See, we don't want to reinvent the wheel.
Mm-hmm.
Okay. All these can be derived from first principles. Okay. Yeah.
Mm-hmm.
Now for your sake, I will derive the easiest formula from first principles so that we can save time. I will
Okay.
derive, I will prove that the derivative of x raised to 2 or derivative of x raised to 3 is 3x squared. Okay.
Okay.
By x
Mm-hmm.
raised to, see, x raised to n is n x raised to n minus 1.
Mm-hmm.
So x raised to 3 will be 3 x raised to 3 minus 1. So x raised to 2. Right?
Right. Okay.
Okay, now
Mm-hmm.
this I can do it now. That's the easiest thing without wasting much time. Now see, my y is f of x and f of x is x cube.
Mm-hmm.
Okay. Now, now when my x changes from x to x plus h,
Mm-hmm.
y will change from y equal to f of x to f of, yeah.
Mm-hmm.
Now see, but my f of x is to 3. So when my x changes from x to x plus h, y changes from x cube
Mm-hmm.
x plus h. Yeah,
Yep.
sure. No, you're understanding.
Huh, sir. Huh.
Now see, my delta y by delta x is f of x plus h minus f of x
Mm-hmm.
on h. Now f of x plus h is x plus h cube.
Mm-hmm.
F of x is x cube upon h.
Mm-hmm.
Okay. Now what is a plus b cube? A cube
Plus
plus
3a square
3
b
x square h
plus 3h square h. X, no.
h square
Yeah, xh square plus 3 into.
h cube.
Oh, sorry. No, sorry. Minus x cube. Yeah.
Okay. That's equal to, I can take h common,
Mm-hmm.
h into 3x square.
Mm-hmm.
Okay. Now this is
Mm-hmm.
delta y upon delta x. Now
Right.
when delta x, which is the h is very small, when
Mm-hmm.
delta x limit delta y upon delta x,
Mm-hmm.
when delta x equal to h tends to 0. It's very small.
Right.
Okay. And then upon h, there's a h here. No?
Mm-hmm.
What happens? All this becomes 0. I have,
Mm-hmm.
when h is very small, what happens is 3x squared plus 3xh.
Mm-hmm.
This will be 0. So I am left with 3x squared.
Right. Okay.
So derivative of x cube is 3x squared.
Mm-hmm.
Similarly, derivative of x squared is 2x. Okay.
Right. Mm-hmm.
Okay. Now we won't bother proving everything. Okay. It is no
Right,
point.
sir.
Okay. This is
Like these
just
are
to
just the base formula I should know.
this is just where you should know how we have got these values.
Right.
Whatever we did, all this is called first principles.
Mm-hmm.
So from first principles we get first.
Okay.
It has come from
Mm-hmm.
first principles. Okay,
Okay.
we've got
Mm-hmm.
all this from first principles. Now, so we have got derivative of sine x and all that. Okay. Now there is, I think we'll solve some questions now.
Okay. Yeah. Correct. Yeah.
It's better now to solve
Hmm.
some questions from differential calculus.
Okay. Mm-hmm.
I think that's a good idea, First
Yes, sir.
differential,
Yeah.
then integral.
Mm-hmm.
Um, where is it going? Here. Can you see this?
Yes, sir.
Okay. I think these are quite simple, but let us. Okay. Okay. Uh, let's say this.
Okay.
We'll solve some of these, then we'll go to this one six.
Okay, sir.
What are you typing?
Just some random notes, sir. So sir, sorry, sir, is this book Pearson only? This book?
This is Oxford.
Ah, Oxford. Ah, okay. So I think that's a bit better, no? Than
But
Pearson. And
I,
people
I
just
have
say,
I have not seen Pearson. And actually,
"Acha, okay."
earlier, there was Michael Hayes. Okay. So that was a very good book. Yes.
Yes.
I'm a big fan of Hayes publication.
Okay.
Hayes publication and Harder Education for Cambridge. Very good
Acha.
books. Because
Okay.
earlier, when it was old curriculum, I've used Hayes book.
Mm-hmm.
I will share Hayes book with you. That's an awesome book.
Okay, sir,
I have
please.
it with me. I'll share it with you.
Done.
Uh, okay, let us start with these.
Okay.
These questions first. What are your subjects?
So my subjects are for high levels are maths, English, and economics, and standard level it is history, German, and what do you call biology.
Okay, that's good. Okay, now find the derivative of each of the following with respect to x
Mm-hmm.
and find the gradient of the curve at that point where x is 2.
Mm-hmm.
Okay, you have to find
Right.
derivative and you have to find gradient.
Mm-hmm.
Okay, now if I say y equal to 6, y, y equal to 6.
Mm-hmm.
No, I told you when y is x raised to n, okay, when y is x raised to n, dy by dx is n times,
X to the power n minus 1.
right? This
Mm-hmm.
is our mantra.
Right.
Okay. So now when y equal to 6 here, what will be the derivative of y equal to 6?
So it will be 6 times 1
No,
to the power 5.
no, no.
So like if I is only 6, no?
Ah, it's a constant.
Oh, then 0.
0, no?
Yeah.
Because you see it is 6 into x raised to 0.
Mm-hmm. Right.
It is 6 into 0 into x raised to 0 minus 1.
Mm-hmm. Right, right. Huh, sir,
See,
correct.
you see what is derivative? Rate of change of y
Rate of change.
with respect to x.
X,
But
yes.
y is
Mm.
not changing, y is constant. You see f of x plus h,
Huh,
one is
sir.
f of x. But f of x plus h and f of x are the same.
Mm-hmm. Correct,
You
correct,
see,
correct.
if I have to draw a graph of y equal to x, y equal to 6,
Mm-hmm.
y,
There's no change at all.
you see it is this graph, no? Straight line.
Correct.
So whether x is 10, 20, 30, x can
Doesn't
change,
matter.
y
No
will
change
not
at
change.
all. Huh.
So derivative of constant is 0. Make a note.
Huh, sir.
Derivative
Okay.
of constant is 0. No, y equal to. So derivative of constant is 0.
Yep.
Okay. Now y equal to 4x.
4x
Hmm.
then, so 4 will come down. So, 4.
Exactly. So dy by
Yep.
dx is d by dx of 4x.
Of 4. Huh.
That's equal to 4 times.
Of x, which is 1. And so 4 times
Okay.
1, 4.
Okay. Derivative of 3x square.
Derivative of 3x square will be um 3x square 2 is coming down. So it will be 6x. 3
6x.
times 2 will 6x.
And derivative of 5x square minus 3x.
Derivative of 5x square minus 3x. 5 square minus 3x is 3 is coming down. So 10 y square. So 10x minus 3.
Brilliant.
Hmm.
This one,
So which one?
EE.
3x to the power 4. 3x to the power 4. Okay, plus 7x minus 3. Minus 7x plus 3. So it will be plus 3 is going this side.
Is it 12x
Uh,
cubed
mm-hmm.
plus 7?
So got it, sir. Then, sir, your answer will be 12x cube minus 7.
Plus 7.
Yep.
Plus 7.
Without, sorry, plus 7. Sorry, sorry, sorry.
Now see, we have got the derivative. Now we have got derivative in terms of x. So we have got the
Mm-hmm.
derivative function. Now we
Mm-hmm.
want to find the gradient of the curve at point x equal to 2. Now see, gradient, okay, gradient of the curve at x equal to 2,
Mm-hmm.
it means gradient of tangent
Mm-hmm.
at x equal to 2. Okay.
Mm-hmm.
So gradient of tangent at x equal to 2. Okay.
Mm-hmm.
Now, now see, now let us say 1a. What is gradient of the curve at point x equal to 2?
Gradient of the curve at point x equal to
1a.
oh 1a. Okay. Y 6. So zero change. I mean gradient will be zero
0.
0. Yeah.
Because derivative is 0.
Gradient is derivative. Okay.
Now, what is gradient of the curve at x equal to 2? See, gradient of curve is the same as gradient of tangent.
Okay.
So what is
Mm-hmm.
gradient of the curve at y equal to 4s at x equal to 2?
Y is equal to 4s and x equals to 2. So you have 4. X is to y is 4. X is 2. So 2. Gradient is 2.
No, 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 no. My derivative is 4, no?
Acha, so gradient is also 4 then.
See, my f of x, y, dy by dx.
Mm-hmm.
Okay. And dy by dx. Okay. So if you
Mm-hmm.
say y equal to f of x, when y is 6, derivative is 0. So
Correct. Hmm.
derivative at x equal to 2 is also 0.
Okay, correct. So always gradient is equal to your derivative, right?
Always. The
Okay.
derivative is defined as gradient. No?
Acha, okay, huh.
The rate of change of x. No? Sorry,
Mm-hmm.
rate of change of y with respect to x. Have you taken physics?
No.
Okay, you know velocity, you know speed is distance upon time.
Correct, the same.
Okay, and now see. Now, if I have distance here and time here,
Mm-hmm.
distance upon time is this. So at
Correct.
any point, draw a tangent, you'll get the speed,
Mm-hmm.
ds upon dt. ds upon dt, distance upon time, speed.
Okay.
Okay, and you don't
Mm-hmm.
bother. Okay, now when y equal to 4x, what is x equal to?
When y is equal to 4x and x is
No,
equal
no, I
to.
mean dy by dx is equal to
Acha, in this case, 4, obviously. 4.
4. So
Mm-hmm.
dy by dx at x equal to 2 is how much?
4.
Now 3x square. No? When y is
Mm-hmm.
3x square, dy by dx is
So 2, 3,
6x.
6x. 6x. Yep. So this is also
At,
6x.
at x equal to 2, it will be how much?
6x.
No, 6 into 2, 12.
Oh, you,
At
correct.
x equal to 2.
Hmm. Okay. Right, right.
Then what is 5x square minus 3x, right?
Mm-hmm. So 12x square. So x square 2 to 4. 12 for the 48. So so that's 10x.
Derivative of
10x, yeah, of
5x.
course, 10x minus 3. So it will be 17.
Have you understood this?
Yes, sir.
This concept? Okay, now let's Neil, just give me 1 minute. Now just wash my face and come. Huh?
Ah,
I'm
okay, okay,
yawning.
no
I'm
worries.
yawning too much. Huh? That's
Uh-huh.
bad manners.
Okay,
Just
okay,
2 minutes.
sir.
Huh? 1 minute. Not
Yes,
only.
sir, of course. Huh, no worries, no worries.
I'm sorry, Neil. Huh?
No, no, sir, no worries.
Okay. Now let's solve some interesting problems now. Okay. These are
Uh,
two bookish. Um, okay. In question number 2, we'll solve the last one. E.
okay.
Okay. Then we will solve
Mm-hmm.
some interesting ones. We'll solve 6. Okay.
Okay.
E. And also we'll solve 3. Question number
Okay.
2 and 3. We
Mm-hmm.
won't solve all of them. I will put this in Google Classroom. You can
Okay, done.
solve the
I'll
remaining.
solve it. Yes, sir.
Because let us solve.
Mm-hmm.
Oh, brilliant. Question number 5. Oh, there's such interesting ones. Eh? Chalo.
Okay.
We have enough time. We can solve.
Mm-hmm.
We can solve. Um, Here it is. Okay, Neil, we will solve only this one. Huh? Part E.
Mm-hmm.
Okay. So part E, what is my y? Is 7 upon x
Part,
cube.
yes, huh? Plus 8x to the power 4 minus 6x square plus 2. I have to find the derivative. So it will be s- 7x. Yeah, plus 8x. Okay. 1 second. 7x cube is what?
I will write a
Uh,
y equal to 7 x raised to minus 3.
mm-hmm. So, the derivative of 7x cube is,
So 7x
is
to the
that,
power
that's a,
minus 3.
acha,
Not
so
x cube,
minus
minus 3.
21,
Uh,
हाँ, तो minus 21 by x to the power 4.
yeah, yeah.
Yeah,
Minus 21 x to the power minus 4, right?
correct.
Plus
Plus
32
32 x plus
x cube, x cube.
minus 2 0 12. X cube minus 12x
Plus 0.
plus 0.
Derivative
Correct.
of 2 0. Now you want to
Correct.
find the derivative at x equal to 1. Okay.
Okay.
So
So at
derivative
1, it will be 1 to the minus 4 is obviously 4 minus 4. 4 is what? all the power. So this will be 1 only. So minus 21
Yes, 21.
plus minus 21 plus 32 minus 12, which is 30, 40, 50, sorry, 30, 20, 30, 32, 33. So minus 1. Huh.
Okay, that's it. Uh, Now this one, 3b. Can you see the
Um,
values? It is
yes, I can see
40
it.
raised to 3 upon 4.
Mm-hmm. So this 43 upon 4. 40 to the power. 40 to the power 3 upon 4. Again, to the 40 to the power 3 upon 4. Though.
So v is 40
40 upon 3 to the power 4. So it will be 3 to the power 4. Yeah. So it will be say 3 by x to the power minus 4. No, 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 not minus 4.
Hmm.
Wait.
Yeah.
Minus 4 only, no?
No.
No, no,
1
no, no, not
upon
minus 4.
1
1
upon
upon
4.
4. Right. 1 upon 4.
You meant this, no?
Yes, correct.
Okay. Okay. Now this is 3 raised to minus 1 upon 16.
16 divided by, okay.
Right?
Correct. Yep.
That is 3.
Mm-hmm. 50. Right.
Oh, 4 that's 16. So plus 4.
Minus plus minus plus and 4 gets squared.
Okay. This is my dv by dt.
T minus 4. Okay.
It is dv by dt, not dy by dx. Huh? Because
Mm-hmm.
here we have got v and t. Now you want to find dy by dt at t equal to 16.
Okay.
Okay?
I'll just get my calci. Yep. So,
Oh, no, Neil, we
mm-hmm.
won't use calci in this. Okay? You try to do
Okay.
without calci. Only when
Okay.
we have to, oh my god, when in integral calculus, when we have to find area at that time, we will use calci. Let us do
Okay.
without calci.
Okay. Then 3t
Dy by
16. So 16 threes. So 16 times 3 equals to 48 to the 40 to the power minus 1 fourth, or 41 by 40 to the power 4. 40 to the power
no, no,
4.
that's equal to 3 into 16 raised to minus 1 upon 4 plus 4 into 16 to the power minus 5.
So basically 3 divided by 16 to the power 4.
1 upon 4.
1 upon 4, sorry.
Okay. Now what is 16? 16 is 2 raised to 4
Mm-hmm.
into
They get cut. Okay. Uh-huh. So 3 by 2 plus 4, so 2 5s are 16, So 16 to 16 and to minus 5. So minus 16. So 4 ones are 4 fours are
3
minus
upon
1
2.
fourth. So 3 by 2 minus 1 fourth.
How many 1 4? Plus
So
4
2
into
to the power 5 is 16, no?
2 to the power 5 is 32,
Acha, oh, sorry. So 1/8. Minus 1/8.
which is 11 upon 8, right?
Okay. Yep, 11 upon 8.
Good. Now we'll see some interesting ones. Okay. This was really bookish. The
Mm-hmm.
profit made by selling C cupcakes is given by this. Yeah, yeah. We'll do this one.
Mm-hmm.
6th and 7th. 9th is there. Okay. I am tempted to solve all.
Okay.
This is a very calculus is a very interesting branch of mathematics.
Uh-huh.
See, actually, mathematics as a subject, it is not meant to be taught in the classroom. It is meant to be taught in the drawing room. Yeah,
Okay.
seriously. Yeah. Now you open Economic Times to see, okay, and mathematics is everywhere. When you're drinking coffee, okay, your coffee mug is mathematics. How the everything is mathematics.
Hmm.
Okay. I don't think we will have time to solve so many, but I think we can solve at least two questions we can definitely solve.
Mm-hmm. Okay. So
Yeah, okay. Anyway, I'll put the remaining in the worksheet. You can,
okay, sir, done.
uh, see, the area of a circle is given by A equal to pi r square.
Mm-hmm.
So what is dA upon dr?
D upon dr is 2 times pi by r. Yeah.
Very good.
So 2 times pi by r.
So when r is to what is the rate of change of area with respect to radius?
Then 4 pi.
Okay, which means rate of change of area with respect to radius is dA upon dr.
Mm-hmm.
Okay,
Right.
at r equal to this 4r. Very good. Now,
Mm-hmm.
yeah, can you see this?
Yep, sir.
The profit made by selling cupcakes
Mm-hmm.
is that's what I call a delicious question.
Okay.
Profit is given by now. This is called now. See, you're given profit as a function of C. C is
Uh-huh.
the number of cupcakes sold. So this is called
Right.
profit function. Okay. P is the profit
Okay.
function. See, this is just
Mm-hmm.
notation. Okay. It
Mm-hmm.
basically it means nothing, and you already know. P is minus
Right.
0.05 C. But they're giving
Mm-hmm.
a word function. Function means relationship. So there is a
Right.
relationship between number of cupcakes sold and profit
Mm-hmm.
made.
Correct.
So P is
Oh yeah. So okay. So this is here the derivative. I'm finding derivative only, no?
yeah dP by
Huh.
dC, rate of
Right.
change of profit with respect to C, number of
Right.
cupcakes sold.
Okay. So it'll be 2 times 5. So 2 times 5 is 2 times 0.05, which is
Zero five six zero
minus
five
0.
six.
Sorry. So 50, 100, 12. Okay. So zero. So 2 times. So minus 0.12
112.
C. 0.012. Oh no, I'm wrong. I'm wrong.
0.112 no
Yeah, that's what I said. No. So 0 point minus 0.012. No,
112
0.112 C
C.
plus 5.6. That's it.
That's my profit.
Yeah.
Sorry, no, that's my derivative, dP by
Derivative.
dx.
Yep.
So find the rate of change of profit with respect to number of cupcakes when C is 20. So when C is 20, what's your profit? No,
Uh,
what's your DP by DC, rate of change of profit?
so it will be 20 times 112, which is 2 to the 4. So it will be 1 shifting. Okay. So 4 to 2.24. 2.24 minus 2.24. Am I right?
2.24, na?
Huh.
Um, 2.24, correct, huh?
Hmm.
2240. So 2.24,
2.24 plus 5.6,
which is
hmm.
minus 2.24 plus 5.6, which is
Which is
uh,
7.84.
no, minus, no?
Oh,
Minus 2
minus.
point,
Sorry. So
3.84, 3.82.
3.82. 2.2
No,
point
5.6 minus
2.24 minus 5.6 is 3.36 minus 3.36.
2.36, no?
Sorry, yeah, correct. Huh.
2.36. And what is the value of the profit when C is 60, dP by dC?
dv by dc
At C equal to 60.
at c equals to 60. Okay, so 60 times 6 to the 12.
You can use a calculator.
Okay, that's easy now. Into 60 is, so it will be 6.72 minus 6.72 plus 5.6.
That's minus
So,
1.12.
right, minus 1.12.
What does this mean?
This mean negative rate of change.
Okay. What else? Okay.
Uh,
One second. See, it means at C equal to 20, your profit is growing.
mm-hmm,
Okay, your profit is increasing. Okay.
mm-hmm,
At C equal to 60, your profit starts decreasing, starts falling.
right.
No, even I am wrong. The rate at which the profit is increasing is positive.
Uh-huh,
At C equal to 20. At C equal to 60, the rate at which profit is
negative.
okay. This means well, it means profit is actually decreasing. No?
Mm-hmm.
That's why no, it's not decreasing. It is increasing at a slower rate.
Yeah.
Okay, see, which means look at it like this. This is my profit curve.
Hmm.
At C equal to 20, my profit is increasing because my gradient is positive. At C
Mm-hmm.
equal to 60, my profit is decreasing. No, again, my goodness, I will get a zero. My rate of change of profit is positive here. Rate of change
Uh-huh.
of profit is negative here.
Negative.
Okay, 20. Which means somewhere between the two, my profit is maximum. Somewhere between,
Excuse me. Sorry.
somewhere between 20 and 60, my
It is
profit is
positive.
maximum. My profit is
A
maximum.
maximum. Yeah.
See, when
Hmm.
my dP by dC is zero,
Mm-hmm.
it will be maximum. No?
Mm-hmm. Correct.
Here my rate of change of profit is positive. So my profit
Mm-hmm.
is increasing.
Mm-hmm.
That's maximum. Now it starts decreasing. Okay,
Yes, sir.
that's certain. This is the meaning of comment on your answer. No?
Mm-hmm.
The distance of a bungee jumper below a starting point is modeled by the function Okay.
Function, okay. Okay. So 10 minus 10t. Yeah, so derivative is 10 minus 10t, where t is between 0 and 2. Okay.
Okay.
Okay, first one is easy. First one is only 10 minus 10 minus 10 minus 10t, and state quantity represented by quantity represented. Okay. So simply below starting point is multiple the function. Okay. T time seconds for each over. So what will be part B? How to state it?
Part, no, what is part A first?
So part A told us 10 minus
Ah, okay,
10t.
yeah, okay, okay, yeah, yeah. Then what is f dash t? F
F
dash
da-
t is
oh
the
oh F
rate,
dash t straight over. F
rate
dash
at
t.
which, rate at which the bungee jumper is following.
Okay.
Okay,
Okay, so
the
that is
speed at
this.
which is following.
Hmm.
No, right.
Then part B, it will be, I think, time quantity
F
represented.
dash 0, F dash 0.5. You put t equal to 0.5. Okay. Your
Mm-hmm.
F dash t was F dash t is 10 minus 10t, right?
Correct.
So at t equal to 0.5,
Mm-hmm.
f dash 0.5,
10 minus 5, so 5.
f dash 1.5
So 1.5 times 10, 15, so minus 5.
minus 5. Now what does this mean?
Negative rate of
Somewhere,
change.
ah, it means here, okay, uh, here the rate at which he is falling is decreasing. His speed
Correct.
is decreasing. Here his speed is increasing.
Mm-hmm.
Okay, so somewhere between the two, it'll be maximum.
Mm-hmm.
See, at 0.5 it's increasing, at 0.5 it's increasing,
Mm-hmm.
at 1.5 it is decreasing.
Mm-hmm.
So somewhere between the two, it is maximum.
Right.
So dp by dc is 0. Okay,
You,
f dash t is
yes, sir.
0. And when is f dash t 0?
When is f 0, it is 0 when I think I have to do an inverse.
No, 10 minus 10 t is 0. No? T equal to
Acha,
1.
acha. Okay, okay, sorry, sir, obviously.
So
Sorry,
which means that t equal to 1. Okay, okay.
T is equal to
Uh,
1. No, this is 0.
uh, his speed is 0. No?
Speed is 0.
He's falling, then he will start returning, start coming back.
Mm-hmm.
Okay,
Correct.
he will fall down and then he'll start returning.
Uh-huh.
Okay, okay, I think we can stop for now. That's too much.
Okay.
And I will put some questions.
Uh-huh.
And so
Fair
I
enough,
think
sir.
it's a good idea. We'll finish off this.
So I was saying that this is already one known topic to me, so I know about basics. I just forgotten. So how about I do the full exercise? The thing you sent me, I'll complete the full exercise. Ah, sir.
and next class, we will finish off this, not this particular thing. We'll
Like
finish
this,
off,
huh?
we'll finish off differential calculus, not
Mm-hmm.
this worksheet. Okay. I think
Yes,
one
sir.
class, see, there is product rule, there is chain rule,
Uh-huh.
and all that we'll finish off. Let's see. I don't think one
Yes, sir.
class, I think we need two classes to finish off.
Okay. Okay.
We'll finish off this and then we will go to integral calculus.
Integral.
Just give me 1 minute. It is, where are we? Ah, no, we have to do, see, higher derivative is there. ठीक है? I think next class what we can do between the next two classes, we'll
Mm-hmm.
finish off complete differential calculus.
Okay. Okay.
Then we'll
Okay.
move
Okay.
to integral calculus. Yeah?
Done. Okay,
With
sir.
these two classes. See, let's stick to an agenda, so that
Yes, of course.
then I will put some videos on these
Mm-hmm.
topics. So then if you go to the videos, and again my video will not be total viewing time will not be more than 30 minutes.
Okay, sir.
So that we will do. So then we can we should try and finish up in one class. But
Uh,
if we cannot do in one class, two classes, but
Done,
not
sir.
beyond two
Okay.
classes.
Okay, sir.
Okay. So thank you very
Yes,
much.
sir. Thank you, sir. Thank you so much, sir.
Today's
Have
session.
a
Thank you.
sir. Then have a great night, sir, and bye, sir.
Namaskar. Namaskar. And
Yes, sir.
today's session we have recorded, so I'll send you the recording.
Yes, thank you, sir. Okay. Bye, sir.